How's it going, everybody? Welcome to CS2304. My name is Michael Irwin, and in this particular lecture, we're going to be talking about emissions controllers and Gatekeeper. So we've got a little bit to talk about, and so let's just dive right in. Well, first, we're going to start talking about why do we need emission controllers, and the way that we're going to illustrate that is by talking about the limitations of the built-in RBAC mechanisms in Kubernetes. I know in the past we talked about roles and role bindings and whatnot, and we'll do a quick review of that, but then also talk about where are the shortcomings there, and from there, then we'll talk about the state acceptance workflow and the various kind of steps that every time you make a state change, it goes through several kind of steps in order for that change to be applied. And we're going to talk about how we can potentially fit into that to control or add a little bit more policy into what gets accepted into our clusters. And then finally, we'll talk about a Gatekeeper, which is a pretty awesome tool, and we'll do some demos around it, and we'll go from there. So let's dive in, shall we? So limitations of the built-in RBAC. Okay, as a reminder, Kubernetes has quite a bit of support for role-based access control to control who can do what within the cluster, and namespaces are a pivotal part of that. So it allows us to carve up our cluster into smaller virtual clusters, and the RBAC mechanisms within Kubernetes give us the ability to control who can do what within the cluster, and we can say, you can do specific things within this namespace, but you can't do anything within another namespace, for example. And as we've talked about before, Kubernetes has very rich support for authorization. Okay, so we can control, you can create these types of objects, but not those types of objects. You can, see these other ones, or whatever. So you can get fairly granular. But Kubernetes has no mechanism for authentication, and we've talked about that previously. So as a quick reminder, we've got roles and cluster roles that define the policies or permissions that can be granted. A role is defined and applied within a specific namespace, while a cluster role is defined kind of at the global cluster view, and then can be applied whether in a specific namespace or across the entire cluster. A role binding is what grants either a role or cluster role permissions to a subject within a namespace, while cluster role binding will give you access to the entire cluster. So that's just a quick review, and here's a sample policy. If I grab the laser pointer here. Okay, so this cluster role is being named pod reader and will give us get, watch, and list access to pods. Okay, and then this role binding is going to bind that cluster role to anybody that's within this OIDC group. So platform example admins, and if you don't know OIDC, don't worry about it. But users that may be in this user group will be granted the pod reader access within this namespace, so the example app namespace. Okay, so pretty basic, pretty simple, and we've done some experimenting with roles and role bindings and that kind of stuff in the past. So just a quick recap. Now, there's limitations to this, and I think this this graphic on the right here hits it spot on, because it provides some security, but there's still a lot of ways around it, or there's a lot of things that you can do that may not be how you want it to work. Okay, so for example, we've got some example policy or some possible scenarios here. How do I ensure that all pods have defined resource limits and requests? So for example, if I want to have a platform environment, I want machines to be able to scale up and down automatically. Well, in order for that scaling to work, the pods need to have resource requests and limits. Well, in the roles and role bindings that we were just looking at, I can say that you can create a pod, but I can't get more granular than that. I can't say you can only create a pod if you have resource requests and limits defined. Okay? Another example might be, how do I disable customers from deploying load balancer services? So in a cloud environment, every time you deploy a load balancer services, provision a new load balancer, which is given or adding additional cost to your platform. So again, the RBAC mechanisms, the roles allow you to say, yes, you can create a service, which everyone should be able to do, but how do you limit it to say you can only create certain types of services? It doesn't get that granular. And there are lots of other examples, pod security policies, which we haven't really talked about, but those are kind of pseudo standards for security. So for example, I don't want to be able to allow people to run privileged containers, or to be able to mount the host file system into a container to be able to make changes on to the host machine. So how do I How do I enforce those kind of things? Okay. And again, so this is getting more granular into you're allowed to define it, but only when certain conditions are met. Okay. And that's the real limitation of the Kubernetes RBAC is that it's really just verb and resource based. You can you can create, you can update, but it doesn't get more granular to let you control when are you allowed to do those specific things. Okay. So let's talk about the state acceptance workflow. And what this is going to cover is all the steps that are actually done every time you do a kubectl apply. It goes through this particular workflow. Okay. So all API requests go through a several step process to determine whether that change is actually allowed to be made. Okay. And so what I'm going to do is I'm going to go through this chart first, and then I'll come back to these bullets up here. So when a request comes in, so I do a kubectl apply. First, an API HTTP handler receives it. Is that a valid resource, et cetera? And you may get 404s or unauthorized, whatever. But the authentication authorization happens next. From there, the object goes through what are called mutating emission controllers, and these are basically other processes, other services in the cluster that receive the object and can make changes to it. Okay, and so those are basically Kubernetes sends the request to these other webhooks, these other services, then the service sends the response back, and there could be one, there could be 100 of these controllers that run, and they all go sequentially. So there could be a series of these controllers that mutate and modify the object that you're trying to save here. Eventually, once all of those are complete, then the object that you're trying to persist is validated against the schema. Is it still a structurally correct object? Okay, so like when you create a pod and you forget the name, or you forget to specify containers, for example, or you mistype a field name or whatever, it's this portion that's throwing an error saying, hey, you're missing a required field, etc. Okay. From there, once we've mutated it, once we've validated that the schema is correct, there's another set of mission controllers that Kubernetes uses to basically pass the request off to these other controllers to determine should this thing be accepted. Okay, and there's a lot of built-in ones which we'll see on the next slide here. But basically, these are responsible for looking at the object and determining should this thing be accepted. Okay, and if it shouldn't be, then it will deny it and it will throw an error back, and the object won't be persisted. And we'll see some examples of that here in just a minute. Afterwards, then the object is persisted to the etcd, which is that shared database between all the manager nodes, and the state is saved. Okay, and so that's the flow that every request, every API change makes in Kubernetes. Okay? Now, what's cool about this is that we can hook ourselves into these different things, and that's what we're going to be talking about here. Okay? Before we do that, I want to talk about a few of the built-in emissions controllers, because actually Kubernetes uses this exact mechanism to add features, add capabilities, but also do a lot of its own validation. So if I try to create a pod in a namespace that doesn't exist, there's actually one of these validating emission controllers that looks to see, hey, is the namespace that you're trying to deploy into, does it exist? And if not, well, it throws an error. Resource quota is another one that you can define what are called resource quota objects and say within this namespace, you're only authorized to use 2 CPU and 4 gig of RAM, for example. And every time that you define pods that have resource requests and limits to them, it kind of deducts how much you have left of your quota. And so this resource quota controller looks to see when you define your next pod, you have enough space in your namespace to be able to deploy this application. And there's a lot of other ones, and I won't go into all of them, but Kubernetes uses this mechanism quite a bit. Okay. What's cool is, again, like I mentioned earlier, we can add our own emission plugins. Kubernetes includes a webhook mechanism so that basically we can define an object and say, hey, I want to be notified whenever an object wants to be created. And you can plug yourself in either as a mutating controller or as a validating controller. Okay. There's some constraints that come along with that, and you need to be honestly really careful doing this, because at the end of the day, you're plugging yourself into the control plane. And going back to this, if you mess up your service here and you accidentally start saying, I'm going to deny everything. Well, if you deny everything, then you can't even accept changes to fix the deny everything. Okay, so you can kind of see how you can easily get yourself caught in a in a bad situation there. So you really want to be careful because it's part of the control plane, and that says control plan, not plane. But oh well, I'll have to fix that typo sometime. Um, so this is what a configuration looks like here to plug yourself in. So this is defining a validating webhook configuration. So this is going to be a validating controller here. The name, won't talk too much about cert manager, but it allows you to kind of inject a certificate and the CA to trust the certificate and everything. And this is going to say, hey, I want to review everything that's going to be in the V1 and V1 beta 1 versions of the just kind of core API. So all the pods and services and service accounts, all that kind of stuff. Okay. And what we're going to do is every time an object is being created or updated, etc., we're going to notify this service. So the service name example service in this particular namespace. And from there, that every time an object is being created, it's going to send a request to that service, which looks like this. And the request is this big JSON object, and it includes a lot of details, including, what was the request and what kind was it, and the actual object, what user performed the action, if this is a change, so it's an edit, and you get both the new object and the old object, and you just get a lot of details. So this is a request object, and then it's up to the service to produce a response object to say, is this thing allowed or not? Okay, and if it's not allowed, it can provide a message, and that's what gets displayed in the CLI or other tooling. In this particular one, it says, hey, you cannot do this because it's Friday and your name starts with an A. So you can make up some really crazy policies. You can say, hey, we're not going to have, we're going to deny deployments on Fridays because we want everybody to have a good weekend. And you can make a policy to do that. Anyway, so it's a pretty flexible system. It allows you to plug in and do your own thing. Now, most of the time, you don't want to write your own plugins for this. Because again, you have to think about how do you protect yourself. Again, we're part of the control plane, but you also want the requests and responses to be handled pretty quickly. You don't want to be a bottleneck in the Kubernetes control plane. And that's where OPA and Gatekeeper come in. And we'll talk about them because what OPA and Gatekeeper do is it provides you basically a policy engine that you can just plug in and you can define your own policies. And then you don't have to worry about all the how to actually receive the webhooks, how do I create the right response out of it and everything. You can just say these are my policies, and we'll see some examples of that here in just a minute. Okay, so OPA is a policy-based control for cloud native environments, and OPA is again a policy engine that's used in a lot of different environments, not just in Kubernetes. And what it's used for is to a lot of times it's like access requirements of can you access this API endpoint or lots of other stuff. But in Kubernetes, we're going to be using it specifically for do we allow certain objects to be accepted. Okay, so policies are written in a language called Rego, and Rego is a kind of a funky language when you first get introduced to it, but it runs incredibly quickly and has some other pretty neat advantages, which we'll see here in just a little bit. OPA is used again in many environments, use cases, and then what Gatekeeper does is it basically surrounds or wraps OPA, that policy engine, and it kind of allows it provides the web server to be able to receive those webhook requests, parse the JSON, and then basically pass the object into the policy engine, where then we can just write our policies, and then it allows us to define our policies using custom resources, which we'll see here in a minute. So again, think of OPA as the underlying policy engine, and then Gatekeeper is this wrapper around it that just makes it more accessible in a Kubernetes environment. Okay, so this is an example OPA policy, and it's written in Rego. And I stole this from their marketing page. It says Rego allows authors to focus on what queries should return rather than how queries should be executed. And I argue with that sometimes because a lot of times it's like, wait, how do I actually run this, or how do I think about this? So let's read through this first one. Okay, so we've got a function here that's called deny, and this is actually the return type. Okay, or it's the return that's going to come out of this. So message we would define if we get to the end of this, and so if a message gets defined, that's what gets returned. Okay, and the way to read Rego is basically reading each statement as truth statements. Okay, so you evaluate each one, and we will only continue execution if that statement is truthy. Okay, so this first statement, we're going to look at it and say input.request, and input.request is going back here, is this big object here. Okay, so the input.request.kind.kind. So in this case was an auto scaling event that this um, example is using here. So what we're doing is saying input.request.kind.kind is a pod. Okay. So then from there, we're going to look to see, well, all right, if it is a pod, we'll continue. If this object is a service account, well, then this will be falsy and we'll stop evaluating this particular violation here. Image, we're going to look at the request object, and the object now is going to be the actual pod spec, the pod document. Okay. So we're going to look at the spec containers. This is going to say, I want to basically iterate over all of the containers, because remember, containers is an array. I'm going to iterate over all the containers and extract the image out. Okay. If I have an image that doesn't start with myregistry.com, I'm going to create a message and say image whatever comes from untrusted registry. So what this example policy here is going to say, I'm only going to allow images that come from myregistry.com to run in my cluster. Okay, so and there are many companies that do this, that say, we're not going to allow images coming from Docker Hub. They have to come from our own internal registry, because they've been vetted and security scanned and all that kind of stuff too. So um, this may very well be a real policy for a lot of people. Okay? And so what Gatekeeper does, again, is it makes it easy for us to define these policies using the custom resources, which we've talked about the last couple of weeks. So it also runs as a webhook emissions controller, so it will receive those objects, those review objects, kind of parse the JSON and then pass it off to our Rego policies. The way that we do it is we define what's called a constraint template, and the constraint templates are created using those custom resources, and then the actual constraints are created using additional CRDs, which we'll see here in just a minute. So in this example, what I'm going to do is I'm going to create a policy that says ingress allowed domain. And what this is going to do is kind of authorize what domains am I allowed to use within a specific namespace. Okay. So I'm going to define a template that has my Rego policy in it. And once we do that, then what I can do is I can actually create other objects called ingress allowed domain. So what happens here is that Gatekeeper takes this template and it actually makes a new custom resource that reflects the constraint template name. Okay, so then I can actually create these ingress allowed domain objects and kind of put additional parameters on them to say, okay, this namespace is allowed to use these domains, etc. And we'll see examples of this here in just a minute. So if you're still a little confused, don't worry. But then it's these inputs that go into OPA and are validated whenever objects are being created, updated, etc. Okay. So here's an example constraint, and this is actually the one we're going to be doing the demo here in just a minute. So I've got a constraint template. I'm going to call it ingress allowed domain, and what this is doing is saying, hey, whenever I define one of these objects, the specification is going to allow me to define domains, which is an array of strings. Okay, and again, we'll see what this looks like here in just a second. But it allows me to kind of create the specification for this new custom resource, and these are going to be the input properties, which we'll see over here, the input parameters that will be used in my Rego. Okay? And so as we go through this, this is going to say I'm going to be looking for ingress objects. I'm going to extract all the hosts out of them, and then I'm going to basically do a match of, is the host that's on this ingress object one of the authorized domains for this namespace? And if not, then I'm going to set a message and say, hey, that's an invalid host name, and you're not allowed to define that host. Okay. So once I've defined that constraint template, then I can actually create the constraint itself. And so in this example, I'm going to say the example app namespace is allowed to use the app.localhost domain. Okay. And that's pretty much how it works. And so that provides the input parameters to the Rego engine. and allows us to evaluate, is, is this new ingress object allowed to be defined. Okay. So with that, let's actually, I'm going to jump over to a terminal here, and we're going to play around with this a little bit. Okay. So what I've got here is I've got my constraint template, and this is the same one that I have in the slides. And so what we're going to do is we're going to go ahead and apply this. And we'll see that the constraint template gets created. And if I get the constraint templates, I'll see that I've got the ingress allowed domain object there. And now to actually plug this in, what I'm going to do is I'm going to use the CS2304 namespace that we've used in some of our hands-on. And I'm going to authorize that namespace to use the name app.localhost. Okay. And so let's go ahead and apply that policy. And now I have an ingress object that's going to go into CS2304. And I'm going to specify a different host name. So in this case, hello world.localhost. Now again, the Kubernetes RBAC, the roles and role bindings, allow me to create ingress objects. Cool. But now if I do this, we'll see that I get an error saying that invalid host, hello world.localhost, and that Gatekeeper is the one that's denying the request here. So if I actually go and change this now to app.localhost and apply it, now it gets created. So that's an authorized domain for that particular namespace. And even if I tried to change it again, let's change it to something else. Let's see if I can, manipulate one that is already there, and it's going to say, hey, that doesn't get accepted. Yeah, the error message here is a little ugly. There's a lot of extra stuff here, but it's, again, tells me it denied the request. It's an invalid host, bad app.localhost. So pretty simple use case here. But like, for example, for us, for my team that's running a platform, we have different tenants in each namespace, and we want to make sure that tenant A, who's running a namespace A, can't define an ingress object that takes the traffic for another tenant, and that they can't, specify a domain name that isn't theirs. Okay, and it's policies exactly like this. Ours are a little bit more complicated because we also validate the domains for like the certificate objects and that kind of stuff. And I didn't put that here in this example policy, but we want to make sure that people are only using the domains that they're authorized to use. Okay. Now, so for this week, the hands-on this week, you're actually going to deploy Gatekeeper and try it out. We're going to start off with a pretty simple policy that just basically flat out denies all pods. And that one doesn't take any input parameters, so that's a pretty easy one to define. And then you're going to define another policy that's a little bit more sophisticated. And in that particular case, we'll be saying, here are required labels that are necessary for pods to be deployed. But again, you can make policies to really do anything that you want. One of the other cool things is that Gatekeeper can also plug itself into the mutation part of the emission process. And so what that allows us to do is kind of mutate objects. And part of the hands-on for this week, you'll actually get to experiment with that as well too. So quite a few different things to try out and to extend the capabilities of Kubernetes. And like we've talked about before, it's this extensibility of Kubernetes that really makes it so powerful and why so many people are interested in using it. Just to be able to run containers is great, but it's now all the extra extensibility, the custom resources, the ability to hook yourself into that emission process and add your own policies or enforcement or mutation. That makes it incredibly powerful. And so hope you enjoy doing the hands-on this week. And as always, if you've got any questions or whatnot, feel free to reach out to me, and we'll go from there. Thanks all.